everybody. I'm a fourth-year PhD candidate from Civil Environmental and Ocean Engineering, and currently I'm working with Dr. Valentina Prigiov. So today I will introduce my PhD projects in nuisance flooding due to groundwater emergence. The first thing I will explain is the groundwater flooding. As you may have heard about, due to the climate change, the direct consequences to this is the sea level rise. And located at the coastal area on the left-hand side is the urban, is a nature catchment, and with the sea level rise, the inland groundwater increases as well, and it triggers the groundwater inundation and the formation of the inland wetland. While at an urban area on the right-hand side, the groundwater level increases will submerge the subsurface infrastructure and eventually flood the urban surface. Such phenomenon has been observed at the city of Hoboken as well. So here in this slide presents the reported locations in the figure on the left-hand side and the flooding figures on the right-hand side. There are no specific sensors monitoring the flooding depth, but comparing with the curb and the car tires, the flooding depth could be around 0.3 meters. So to better understand the groundwater condition, we installed the sensors to monitor the at the monitoring wells to continuously monitor the groundwater condition. And in parallel, we use the data collected from sensors and also from other various sources such as precipitation data and temperature data, barometric pressure data from NOAA and other sources to do a numerical modeling to do cross-validation with the field measurements. In this slide, the first figure is a sensor we used in the field, and the second is the monitoring well on the streets, and the last is when we're going to download the data periodically. So with the monitoring process, theoretically, the longer the sensor stays in the well, the more stable the data is. And when we install the sensors to monitor the groundwater in Hoboken, the left-hand side figure is our group. And in this project, I want to acknowledge the visiting students from Norway and Italy, Mariam Prigiov, and also the master students from Steven Sneha, and also Tim Liu has helped me a lot with the modeling parts. They help a lot in this project. So here the left figure shows the major monitoring wells that we have in Hoboken, and we're still trying to find more wells. The diagram on the right-hand side are the water level measurements comparing with the river level measurements, and the precipitation data from NOAA monitoring stations. So for the modeling part, we implement the model with Buffalo and GMS. Pre-data analysis is using MATLAB, and map processing is using ArcGIS. And the graded model on the right-hand side is showing the model has two layers with 15 by 15 meters grid. So the preliminary results is shown in the slides. The map on the left-hand side is the water level interpolation and the simulated water level upon hydraulic property optimization. And comparing with the diagram on the right-hand side, the simulation agrees with the measurements very well. So upon the current groundwater condition, the slide showed the preliminary results of nuisance flooding at each sea level rise scenarios. And it's very clear that with current high tide, the groundwater will exceed the ground at some low-lying locations. And with the sea level rise of 1 meter, almost half of the city can be flooded, which is a near future. So what I found from the projects is that groundwater has become a very serious problem recently at some coastal areas, and it's time to pay attention to this situation, even if it's beneath us and even if we don't see it. So to maintain the sustainability of the city, we will have to do something with it. So hope you're interested in this project and thank you very much.